My name is Mazi. I'm a resident of Sacramento, California. I've lived in this house for 12 years. I installed my solar system back in 2015. I think I have 7 kilowatt of solar system. Back then, SMUD was okay, and that's my utility. They're giving me full retail for the exports. And so I was happy with that, but there's always power outages. We have in the summertime, there's public safety shutoffs, and it's also a really cool toy to have. So I've been thinking about adding a battery storage. And also I know the utilities are changing the tariffs, so they will not be paying retail for the export, so that really reduces the benefit. Now it doesn't impact me directly, but I mean that's why the state government, the Public Utilities Commission, they're encouraging people to install PV with batteries. I installed the battery storage system about 3 months ago. And it's a 16 kilowatt hour battery storage system. They have a very cool app on my phone. I can go in there and monitor not just what the battery storage system is doing, but also what the PV system is doing and the loads in the house. I actually figured out some interesting stuff is going on in my house without that was not related to the PV or battery storage system, what they call the parasitic loads. I had very high parasitic loads. These are like all the plug-in stuff. So on my phone, that allows me to change settings, for instance, for compensation or how the battery operates. There are several options, allowing the battery to get charged from the solar when the rates are low. It'll keep that charge until the onset of the peak period when the electricity is the most expensive in SMUD territory, and I think that's true everywhere. It's called the time of use rates. So I've been monitoring, and it does exactly that. It charges from the solar. Right now, when the electricity is cheap and there's plenty of sun, it will hold it until 5 o'clock. And when 5 o'clock rolls around, then it starts discharging. It will support the house loads. And then if there's anything remaining, it will basically support the house through evening. So that's a really, really cool feature.
Yeah.
I had the prices from some other competing vendors. I thought this one was less expensive. And there were other features about this that I liked. It actually, if you look at this, it has a very low profile. Actually, it's very cool looking. It's got a low profile, and I get 16 kilowatts. And so this is 11 inches tall, and it's an 8 kilowatt hour battery. That's one of the cool features is that in the future, if I want to add another 8, it's really easy. It will just raise this profile by another 11 inches. It's really modular. So if I want to add 8 or another 16, it's still it'll fit in this space. So that was one of the features that I liked. So it was lower in price than some of the competitors, and I really like the modularity. So I didn't have to decide on the spot exactly how much I wanted, and I can always add to it. The other cool feature that this has is this inverter. They call that the hybrid inverter. And what this does is it'll support both the PV and the battery storage. Normally, you have an inverter just for the panels. You have an inverter for the battery, so you end up with 2. So more inverters means more cost, and it also means more loss, round-trip losses. So by having only one inverter here, you don't require inverters for the PVs anymore. So that makes PV expansion easier too. So that's another feature that I really like.
Very cool.
So in the future, if I get another electric vehicle, which is very likely, and I feel like I need more PVs, then it'll be a much less expensive endeavor.
Good, good.
The decision about the size and the profile of the battery storage system was something that I considered, because when you look at this wall here is fairly space constrained. There's existing equipment here, there's a vent there, so this is about the only place where I could have this, and I felt like this was the appropriate form factor, because even though I'm getting 16 kilowatt hours of a battery storage system, it's relatively low profile, and it allows future expansion very easily, and I have all this space to work with. So if I want to add another 8 kilowatt hour, it just raises this profile by another 11 inches and another 11 inches. So, and I felt like some of the other products may result in a spatial problem here, because I'm very space constrained. And so this actually was the right, has the right footprint and the profile, for the amount of space I have here. I noticed that the neighbors, it lasted for about 5 minutes. But in my house there was a blink, and then the power was restored, and so it continued normally, all the operations. I was watching TV, the lights were on, the fridge was working, and then about 5 minutes later the power was restored. And so I didn't even notice when the power came back. There was no flicker of the lights or anything. So yeah, there was that one incident, and it worked as it expected.
Good.
Okay, so this comes with a really cool app, and there's a couple of features here that I used very often. There's a lot of little features in here. I don't use all of them, but this power flow part of it is what I actually look at a couple of times a day at least. And this tells me exactly what's going on in the house. Like for right now, it is telling me that my PV is generating 2.4 kilowatt. The house load is 1.8. So I got an extra 0.8 kilowatt that's going into the battery. So it's charging the battery right now. And my battery is at about 73%, which means in a couple of hours the batteries are going to be full. So even though I got 16 kilowatt hours, it means I'll still be exporting back to SMUD, my local utility. So this is the one I use very often, and it also tells me when the charge and discharge is happening for the battery. Like I said, at 5 o'clock when the SMUD's highest rates kick in, then the battery switches from charge to discharge, and you'll start sending power to the house to support the house operations. And again, this is the other one that I use because it tells me actually what's going on in the house. Like, sometimes I notice because of this app that in the middle of the night, I still have a 400 or 500 watt load when I didn't think I should have any. And so that got me thinking. I started checking the different circuits, and I found that all these little plug-in devices, you have chargers, your fridge, and all that. They call those vampire loads. You don't think they're drawing. The entertainment center, they're all drawing some power. Your subwoofer is sitting there, it's drawing. So you may want to do something about it, and I've actually started doing things about it. The other feature of this app that I like is when you scroll down, it's called the energy balance. So it's got 2 graphs in here, and this helps me understand whether I got enough PV on the roof to support my daily loads. So right now we're kind of a mild summer day, and so when I checked this yesterday, there was some air conditioning load, and it's telling me basically that I generate enough power this time of the year to support the house loads. It's about 28, 29 kilowatt hours that I'm generating and using. So this suggests that my PV actually is the right size. But then there's another graph right next to it, which says, what percentage of that total generation, that 29 kilowatt hour, is used for self-consumption versus it gets exported back to the grid. And it's basically telling me that I'm self-consuming 43%, even with the 16 kilowatt hour battery storage system. So to me, that suggests I may need another 8 kilowatt hour of battery. So it's got actually information here for the homeowner to kind of get a feel for what the house is doing, what the PV is doing, what the battery storage is doing, and whether you have the right amount of each component, and how much you may need to actually totally balance the system. First off, it helps you optimize the system because you have different operating modes, that comes in here, minimizing exports, maximizing, savings to the homeowner. So, this will help you decide which one of, those features you want to enable. I mean, I had it in the beginning on minimizing exports, then I switched it to basically maximizing the economy. Storing during low periods, discharging during high periods, and there's other options. So by looking at these numbers, you can decide which one of those are a good option. The other reason is that again, I knew I had a PV system up there, but I really didn't know whether that was enough or not, because you get a bill from SMUD, but it's not very intuitive. They do tell you, like, on the monthly basis, roughly what you're doing. But here you can actually look at your system in real time and actually optimize. Like, so one of the things I noticed that was happening is that when I plug in my EV in the middle of the day, you'll start, basically all the solar, the PV, it goes to support the EV charging, because EV charging, it draws so much power. And so you don't get anything into the battery anymore. So by looking at this app, then you realize, what's going on, and maybe you want to adjust, the times you want to charge your vehicle, run your washer, dryer, all the big electric loads. The other thing that I do is by looking at this is like, before the onset of the highest peak, which is about 5 o'clock, the air conditioning load would get very expensive. So sometimes I run the air conditioning maybe from 3:30 to 5, then to pre-cool the house. And then I turn it off at 5 o'clock, and it's good. If it's not a super hot day, in July it was so hot it wasn't working too good, but on days like this, it actually works pretty well. So, looking at this app, gives you some of this information, so you can optimize the operation of your house.
Very good. Is I'm going to go in and I'm going to turn off the main coming in from SMUD, the utility company. And by doing that, you might have heard the 2 clicks there. That actually converted this over to be 100% off grid. Okay, so as we can see here, we're now standing inside the kitchen. We're 100% running off grid right now. We've got a camera set up here towards the living room, and we can actually see we've got TV still turned on, we've got lights still turned on. So everything is 100% being powered by the PointGuard battery system and the PointGuard load hub as well. And we're just going to do the exact process, just in reverse. So this button here, the red on off, go ahead and hold that down for a few seconds. Now we could hear a couple things sort of clicking and engaging. If we come over here to the side of the battery, might be a little hard to see just due to the direct sunlight, but we can see a blue light ring right now around the outside of the display. That's the battery initializing and turning back on. And now we've got an indicator right here that just turned back on, letting us know that battery power has been restored. Everything is totally disconnected. There's no power, no solar, nothing is showing here on the system. So we've been totally turned off. Again, we turned off the Wi-Fi when we shut down this system because there was no power to the house. But if we wait a little bit of time, we will see that this turns back on. Okay, there we go. Okay, and as we can see, we had our reaction camera here. Everything just turned back on, lights are back on. We hear a couple of noises of things flickering. Those are just various items around the house at the moment. But everything is turned back on. Lights, power, I can see the cooktop has power, the clock light is flashing. So again, that was a really quick simulation on exactly what happens when we actually fully black start the battery system. In other words, we turn the system entirely off, turn it right back on, showing that the battery has the capabilities to do that, where a lot of other batteries on the market aren't going to be able to do that.